Welcome to my number one HSC Leslie Bones YouTube channel.
Hi guys, today we are going to look at electrical safety for construction. Electricity, the dangers. About 5 workers are electrocuted every week, cause 12% of young workplace deaths. Takes every little electricity to cause harm. Significant risk of causing fire. Electricity, how it works. Electricity is a flow of energy from one place to another. Require a source of power, usually a generating station. A flow of electron current travel through a conductor. Travel in a closed circuit. Electrical terms. Current, electrical movement measured in amps. Circuit, complete part of the current, include electricity source, a conductor and the output device or load, such as lamp, tools or heater. Resistor, restriction to electrical flow. Conductors, substance like metals with little resistance to electricity that allow electricity to flow. Grounding, a conductive connection to the earth, which acts as protective measure. Insulator, substance with high resistance to electricity like glass, porcelain, plastic and dry wood that prevent electricity from getting to unwanted areas. Let's look at electrical injuries. There are 4 main types of electrical injuries. Direct, 1. Electrocution or death to the electrical shock. 2. Electrical shock. 3. Burn. Let's look at indirect, which number 4 is fall. Let's look at electrical shock. An electrical shock is received when electrical current passes through the body. You will get an electrical shock if a part of your body completes an electrical circuit by touching a live wire and an electrical ground, or touching a live wire and another wire at different voltage. Shock severity. Severity of the shock depends on paths of current through the body, amount of current flowing through the body arms, duration of the shocking current through the body. Low voltage does not mean low hazard, as you can see the example in this picture. Dangers of electrical shock. Current above 10 mA can paralyze or freeze muscles. Current more than 75 mA can cause a rapid infective heartbeat. Death will occur in a few minutes unless a defibrillator is used. 75 mA is not much current. A small power drill uses 30 times as much. Let's look at effect of electrical shock as per the chart below and these photos. 1 mA slightly sensation, 5 mA sensation of shock, 10 mA painful, 15 mA can paralyze or freeze muscles, 50 to 100 mA can kill in a second. Let's look at burns. Most common shock-related injury occur when you touch electrical wire or equipment that is improperly used or maintained. Typically occurs on hands. Very serious injury that need immediately attention. As per the photo, this is one of the example shown. let's look at fault. Electrical shock can also cause indirect injuries. Workers in elevated location who experience a shock may fall, resulting in serious injuries or death. Electrical hazards and how to control them. Electrical accidents are caused by a combination of three factors: unsafe equipment and or installation, workplace made unsafe by the environment, and unsafe work practice. This is one of the examples of this photo.
Hazard: exposed electrical parts. What can you see on this picture? Cover removed from wiring or breaker box. Control: isolate electrical parts. Use guards or barriers. Replace covers. Let's look at this picture. Guard live parts of electric equipment operating at 50 volts or more against. Control: isolate electrical parts, cabinets, boxes, and fittings. As you can see on this observation picture, conductors going into them must be protected and unused opening must be closed. Control: close openings. Junction boxes, pull boxes and fittings must have approved covers. 2. Unused opening in cabinets, box and fittings must be closed. No missing knockouts. As you can see in this picture, photo shows violation of these two requirements. Hazard: overhead power lines, usually not insulated. Example of equipment that can contact power lines: crane, ladder, scaffold, backhoe, scissor lift, raised dump truck bed, aluminum paint roller. This is an example of overhead power line in this picture. Control: overhead power lines. Stay at least 10 feet away. Post warning signs. Assume that lines are energized. Use wood or fiberglass ladders, not metal. Power line workers need specific training and PPE. Let's look at hazard: inadequate wiring. Hazard: wire too small for the current. Example: portable tool with an extension cord that has a wire too small for the tool. The tool will draw more current than the cord can handle, causing overheating and a possible fire without tripping the circuit breaker. The circuit breaker could be the right size for the circuit but not for the smaller wire extension cord. You can see in the picture, wire gauge measure wire ranging in size from number 36 to 0, American wire gauge AWG. Control: use the correct wire. Wire use depends on operation, building materials, electrical load, and environmental factors. Use fixed cord rather than flexible cords. Use the correct extension cords. As you can see in the picture, must be 3-wire type of design for hard or extra hard use. Let's look at hazard for defective cords and wires. Plastic or rubber covering or insulation is missing. Damaged extension cord and tools. As you can see the observation on these photos. Hazard for damaged cords. Cord can be damaged by hugging door or window edges, staple or fastenings, abrasions from adjacent material, activity in the areas. Improper use can cause shock, burn or fire, as you can see on this picture. Control cords and wires. Insulate live wires. Check before use. Use only cords that are 3 wire types. Use only cords marked for hard or extra hard usage. Use only cords, connection device and fitting equipped with strain relief. Remove cords by pulling on the plugs, not the cords. Cord not marked for hard or extra hard use or which have been modified must be taken out of the service immediately. As you can see in this picture, blue stands for neutral, green yellow stands for hard, and brown is for live. Permissible use of flexible cords. Do not use flexible wiring where frequent inspection will be difficult or where damage will be likely. Flexible cord must not be run through holes in walls, ceilings, floors. Run through doorways, windows or similar openings unless physically protected. Hidden in walls, ceilings, floors, conduits or other raceways. Let's look at grounding. Grounding creates a low resistance path from a tool to the earth to disperse unwanted current. When a short or lightning occurs, energy flows to the ground, protecting you from electrical shock, injury and death. Hazard for improper grounding. Tools plugged into improperly grounded circuit may become energized. Broken wire or plug-on extension cord. Some of the most frequently violated OSHA standard. Let's look at control ground tools and equipment. Ground's powered supply system, electrical circuit and electrical equipment. Frequently inspect electrical system to ensure path to ground is continuous. Inspect electrical equipment before use. Do not remove ground plugs from tools or extension cords. Ground exposed metal parts of equipment. Control. Use GFCI, ground fault circuit interrupter. Protects you from shock. Detects difference in current between the black and white wires. If ground fault detect, GFCI shut off electricity in 1/40 of a second. Use GFCI on all 120 negative volt, single phase 15 negative and 20 negative amphi receptacles or have an assured equipment grounding conductor program.
Control. Assure equipment grounding conductor program. Program must cover all cord sets, receptacles, not part of a building or structure, equipment connected by plug and cord. Program requirements include specific procedures adopted by the employer, competent person to implement the program, visual inspection for damage of equipment connected by cord and plug. Hazard: overloaded circuits. Hazard may result from too many devices plugged into a circuit, causing heated wires and possibly a fire. Damaged tools overheating, lack of overcurrent protection, wire insulation melting, which may cause arcing and a fire in the area where the overload exists, even inside a wall, as you can see in the photo. Control: electrical protective device. Automatically open circuit if excess current from overload or ground fault is detected, shutting off electricity. Include GFCI, fuse and circuit breaker. Fuses and circuit breaker are overcurrent devices. When too much current, fuse melt, circuit breaker trip open. Power tools requirements: have a 3-wire cord with ground plug into a grounded receptacle, or be double insulated, or be powered by a low voltage isolation transformer. Tool safety tips: use gloves and appropriate footwear. Store in a dry place when not in use. Don't use a wet or damp condition. Keep working area well lit. Ensure not a tripping hazard. Don't carry a tool by the cord. Don't yank the cord to disconnect it. Keep the cord away from heat or oil and sharp edges. Disconnect when not in use and when changing accessories such as blades and bits. Remove damaged tools from use. Preventing electrical hazard tools. Inspect tools before use. Use the right tool correctly. Protect your tools. Use double isolated tools. These are the example of double isolated marking. You can see in the photo here. Temporary lights. Protect from contact and damage, and don't suspend by cords unless designed to do so. Clues that electrical hazard exists: trip, circuit breaker or blown fuses, worm tools, wires, cords, connections or junction boxes, GFCI that shut off a circuit, worn or frayed insulation around wire or connection. Lockout and tagging circuit. Apply locks to power source after de-energizing. Tag deactivated controls. Tag the energized equipment and circuit at all points where they can be energized. Tags must identify equipment or circuit being worked on. Safety related work practice. To protect workers from electrical shock, use barriers and guards to prevent passage through areas of exposed energized equipment. Pre-plan work, post hazard warning and use protective measure. Keep working space and walkways clear of cords. Safety related work practice. Use specific insulated tools when working on fuses with energized terminals. Don't use worn or frayed cords and cables. Don't fasten extension cords with staplers hung from nails or suspended by wire. Preventing electrical hazard planning. Plan your work with others. Plan to avoid faults. Plan to lock out and tag out equipment. Remove jewelry. Avoid wet condition and overhead power lines. Avoid wet conditions. If you touch a live wire or other electrical component while standing in even a small puddle of water, you'll get a shock. Damaged isolation equipment or tool can expose you to live electrical parts. Improperly grounded metal switch plates and ceiling lights are especially hazardous in wet conditions. Wet clothing, high humidity, and perspiration increase your chance of being electrocuted. Preventing electrical hazard. PPE, proper foot protection, not tennis shoes, rubber insulating gloves, hood, sleeves, matting and blanket, hard hat, insulated, non-conductive. Preventing electrical hazards. Proper wiring and connectors. Use and testing GFCI. Check switches and insulation. Use 3-prong plugs. Use extension cords only when necessary and assure in proper condition and right type for jobs. Use correct connectors. Training employees working with electric equipment in safe work practice include de-energize electric equipment before inspecting or repairing, using cords, cables and electric tools that are in good repair, lockout, tagout, recognition and procedures, use appropriate protective equipment. Summary: hazard and protection. Hazard: inadequate wiring, exposed electrical parts, wires with bad insulation and grounding electrical system and tools, overloaded circuit, damaged power tools and equipment, using the wrong PPE and tools, overhead power lines. All hazards are made worse in wet condition. Protection measure: proper grounding, use GFCI, use fuses and circuit breaker, guard live parts, lockout, tagout, proper use of flexible cords, close electrical panel, and training. Summary: electrical equipment must be listed and labeled, free from hazards, used in the proper manner. If you use electrical tools, you must be protected from electrical shock, provided necessary safety equipment. Thank you for watching. Don't forget to like, subscribe and comment.